This video is on net ionic equations. So what I'm going to do is I'm going to show you three different types of equations: molecular, ionic, and net ionic. Net ionic is our final goal. Molecular is what you've been writing this whole time. So let me give you these kind of notes, examples, and then of each one, and then we'll do an example all at the end. So a molecular equation is an equation that is written with complete compound formulas. For every reactant and product. So this would be something like if I had Na2S and it was aqueous and it reacted with copper 2 nitrate, that was also aqueous. So here we have a double replacement precipitate reaction. So our reactants, or our cations, will switch places. So we will get sodium with nitrate, which will be aqueous, because all nitrates are. And then copper with sulfur will be a solid. If you look up sulfides, they are typically solid precipitates. And you need a 2 right here to balance this reaction. So this is a molecular equation. This is what you've been writing this whole time when we talked about equations. So now that we know that ionic compounds and things can ionize, let's write an ionic equation. This is an equation that shows what takes place in solution. So all of our ionic compounds that are aqueous will separate, will dissociate. So aqueous compounds are written as ions. And I'm going to make a little note because they are dissociated in solution. And then solid compounds are written as complete formulas, because they are not separated in solution. So what we'd get here was Na2S aqueous will split up into Na plus aqueous and S minus 2 aqueous. Now we have to be balanced here still because it was Na2S. We have 2, that means we have 2 sodium ions. The copper 2 nitrate will be copper plus 2 aqueous. And the nitrate, there's 2 of them, so 2NO3 minus aqueous. Right? Because those are all ionic compounds that are aqueous. And then on our product side, we're going to have 2 sodium ions that are aqueous. Oops. And 2 nitrate ions that are aqueous. You see how this is still balanced? And then our copper sulfide is a solid, so that does not dissociate. So I'm just going to write that as is. So when I went from molecular to ionic, I just took my compounds like this that are aqueous and ionic, and I changed them into their ions. Just like the dissociation equations we did before, now we're just doing them all together. Okay, so the last piece then is what we call a net ionic equation. So this only shows components involved in making the solid. Ions that aren't involved in making the solid are called spectator ions. They're spectators, they're just watching, they're not involved in the play. So we don't write them here. So I'm going to look back up here at my ionic equation, and I'm going to see what is the same on both sides. So I have Na plus, 2 Na plus on both sides. That means it's a spectator. It stayed the same, it didn't change, so I am not going to write that when I do my net ionic equation. So what else stays the same on both sides? You can see, hopefully, that these 2 stay the same. Your 2 NO3 minus. So those we're not going to write. So what do we have left? Well, we have the sulfur, that's aqueous, the S minus 2, the copper ion, that's aqueous, and may make the copper sulfide, that's solid. So these are the things that make our solid. So a net ionic equation is only those components. So I have S minus 2. Actually, I'm going to do this in green. So we have S minus 2 that is aqueous, plus Cu that is plus 2 that is aqueous, and that makes CuS solid. And you can see charges and atoms are balanced here. So our end goal is a net ionic equation. That's this right here. So we had to write the other ones to get to here, though. All right, so let's do another example from start to finish. So it says write the net ionic equation. So I'm going to first write my molecular equation. All right, so Fe2SO4 taken 3 times. Fe2SO4 3 times aqueous reacts with lithium hydroxide that is aqueous. All right, so double replacement. So our iron is going to react with or combine with our hydroxide, and it's iron plus 3, so I'm going to have FeOH taken 3 times. And I'm going to get lithium with sulfate. Lithium is plus 1, sulfate is minus 2, so we're going to get Li2SO4. All right, so here's where you might have to look at your blue sheet, and you're going to look up hydroxides, and hydroxides are typically solids unless they're with an alkali metal, calcium, strontium, or barium. All right, so that's not any of the exceptions, so this is a solid. Sulfates are typically aqueous unless they're with strontium, barium, mercury, or lead, so this is aqueous. All right, molecular equation done. All right, so let's do our ionic equation. So we split up all of our aqueous compounds into ions. Make sure you balance it. So look at those subscripts. So there are 2 Fe plus 3 ions that are aqueous, and 3 SO4 minus 2 ions that are aqueous. We've got lithium, that's a plus 1. Oops, I forgot one thing at the other one. Sorry, guys. I hope you figured it out. I hope you're wondering, what is she doing? I did not balance it. So I need, let's see, 2 irons. So here, that will give me 6 hydroxides. So then I need a 3 here. All right, so going back to my ionic, it's 6 lithium ions, 6 hydroxide ions. All right, so my solid stays the same. Doesn't dissociate as a solid. It must be aqueous. And then 6 lithium ions. And I'm going to squish this down here. 3 sulfate ions. Okay, so now when we write our net ionic equation, we're only going to write the things that make the solid. So I'm going to look at things that don't change. So like our 6 lithium is on both sides, as is the 3 sulfate ions. So what I'm left with for my net ionic equation is 2 iron plus 3 ions that reacts with 6 hydroxide ions to form 2 FeOH taken 3 times as a solid. So my answer is this in red right here. So that is how you go from a molecular equation to a net ionic equation.